All right. I guess we can start. We'll just give everyone 1 minute. Busy time. But thank you for joining. All right. So I guess we'll start. Hello everyone. Welcome to the latest Code Intelligence webinar. I am Josh Grant. I'll be leading the webinar today. And today we're talking about how to find Log4j in 10 minutes using automated fuzzing, or fuzzing in general, I guess. This is a nice, easy breezy webinar. We're going to be talking about Log4j, everyone's favorite vulnerability, and kind of how to find it. So your speaker today. Hello again. I am Josh Grant. So I'm a developer advocate at Code Intelligence. I work primarily with Java, but also with JavaScript and my favorite language, Python. And I am all about trying to help people get to use fuzzing, get to use Code Intelligence's various technologies and tools. And I am located in lovely Toronto, Ontario. So here's a nice shot of West Queen West, nice little neighborhood if you're ever in town to join. That's where I'm coming from today. And let's get right into it. So here is Scott Hanselman, a very well-known kind of Microsoft personality in the Microsoft world, in the development world. And he kind of mentions how, yes, we live in a world where maybe your light bulbs are susceptible to the Log4j vulnerability. So this was actually something that he mentioned just this month, just a few days ago, on February 3rd. And so Log4j is still out there, and like he says, it could pop up in a surprising place. So before I jump into it, let me kind of give an overview of what we're going to kind of cover today. So I'm going to give a little background. What is the Log4Shell or Log4j vulnerability? Why is it so bad, in case you haven't heard that before? And then I want to jump into how you would find this using fuzzing and using Code Intelligence. So, and the format I'm going to take there is I'm going to show a very simplified toy example of what the vulnerability could look like, or a similar vulnerability. And then I'll walk through how you would actually find, using Log4j, using a Log4j source, or not the source, I guess, but using the actual Log4j library, how you would kind of find this using fuzzing. So let's get into it. So what's all this then? So December 2021, if you can think all the way back to then, there was a CVE that was open 44228, and it was opened regarding Log4j. So this is the so-called Log4Shell. So this was a CVE that was opened up. It was given a 10 out of 10 rating on severity because... and so if you're not familiar, so CVEs are critical vulnerabilities that are kind of found and reported by various reporters. And there is a severity rating. 10 out of 10 is the highest severity rating, so very severe. And likely it was given this severity because Log4j is a utility that's extremely common in Java code bases. Over my career, I think I've seen the dependency Log4j used in about 80 to 90% of the projects or Java projects that I've ever seen. Very common, but it's also a relatively easy exploit or a very easy flaw to exploit to trigger a remote code execution. So remote code execution allows a remote actor or a remote source to take over and sort of so-called pop a shell and take over a system. So this is pretty bad. It sounds pretty bad. It's an easy exploit. It's found in a lot of places, in a lot of different contexts. Java's found in a lot of contexts. Like Scott Hanselman kind of mentions, your light bulb could have a JVM in it. My cable box has a JVM in it. If you work for a very large company, you're probably running Java somewhere for something. So this is pretty bad. It was a pretty big deal, pretty big exploit. We're still talking about it a year later. But let's go back. Let's go back to the beginning. Let's talk about what Log4j is, and how this exploit sort of came about, like what it looks like. All right, so what is Log4j? So Log4j is a common utility, common logging utility, or a logger. So created by the Apache Software Foundation. So Apache creates all sorts of software, open source, well known for various things, Kafka, all sorts of utilities. Log4j has been around for quite a while. So what is a logger? So a logger is if you're not familiar, is a very common piece of software, not just in Java, not just in sort of the Apache world, but in any programming language. And so a logger is a common piece of software that keeps track of information about what your system is doing, and sort of logging at various places, right? So you might have a code path that, for example, if you have a login flow, maybe you want to record that user logged in successfully, or you want to log in that user did not log in successfully because they have incorrect credentials. Or if you have something kind of internal to your system, maybe a service is called, or maybe like a database connection is made somewhere under the hood, you might want to log that various places. So common uses for loggers are to show information to end users, or like some applications are end users information. So you were able to log in, you're unable to log in, sort of so-called info. I can show an example of this. Signaling errors in software. So if something happens, if an exception is thrown, if something is unable to be processed, a logger might be able to raise this error and kind of let the developer know, or let the end user know that you have an error. And also kind of logging for backend. So if you have a complicated system or a web application, for example, you might want to just log all actions getting taken at a given point in time. If you're an operations analyst, if you're an operations engineer, if you're a security engineer, you just might want to be able to get in and figure out, like, okay, what happened when. So loggers, very common, very straightforward pieces of software. So since loggers need to send all sorts of data to multiple sources, Log4j, being a sophisticated logger, allows logs to be sent to different contexts or locations that may or may not even be in the code base. So for example, so a user tries to log in and they have incorrect credentials. So an error is logged, right? And so who needs to know about this error? Well, first of all, the end user might be needed to show this. You might want to tell them, like, oh, you have invalid credentials, please try again. The backend service might need to know about this. You might want to log to the backend service. There was a login attempt, it was a failure, and that kind of thing. Or to an external database. So like perhaps you want to log in like certain actions and kind of log them into a database or some kind of data warehouse so that can be analyzed later, right? How much traffic is being processed, or what are users trying to do, that kind of thing. So in the case of an external service, like an external database or something else, so Log4j does have the ability to handle different contexts and have a lookup functionality that can be used to look up a database service or connect to it, or an external service in general. So not just a database, but maybe you have an external service running that collects data or collects logs, and Log4j is able to connect in a variety of ways to this. All right, so here's the example. What's the problem? What's the problem exactly? So here's an example, kind of made up. Suppose you want to connect to a local Postgres SQL database. So let's say you have a machine and it's running a Java service, like a Java web application or some sort of internal service. And also on that same machine or in that same network, you have a database. You have a Postgres database. So here's what you could do using Log4j to connect. So you kind of define this context and you say, okay, in this context, look up this service connecting using this string. So this is able to connect to a Postgres database. There's other examples as well. And then once you look up the service, you can try to connect to it here and then kind of go on from there. So So if you are using Log4j, you might say, okay, log to this database, log to this service. This looks pretty good, but I want to highlight that one, this is a pretty general lookup functionality. So you can kind of just look up any old thing. And also that the lookup can take a string parameter. So you can arbitrarily pass in a string, right? So this might be fine if you're an application developer and you know what you're doing and you have specific things you want to connect to. But if you are a malicious actor, if you are kind of exploiting this functionality, maybe you pass in a malicious location. So you say, okay, look up and connect to this malicious script or to this database source. And that's where the problem kind of arises. So again, because this is a generic string, because context lookup takes just a string parameter, you could pass in something like this that's malicious. Excuse me, just one moment. All righty. So this, perfectly reasonable. Java developer has to connect to a database. This, kind of bad news bears. You might connect to some kind of malicious source that maybe a malicious actor can use to take control of your system or collect data or that kind of thing. So, and if a logger received malicious inputs from a user, like this is kind of the core of why Log4j was rough and why it was so severe, was that if a malicious actor is able to pass in malicious inputs to the logger, it could pass this downstream into this lookup. This lookup could be used to connect to like a malicious service or something that could then in turn get a remote code execution, remote connection into your system. And well, this is just not great. So like this could happen. You know, kind of the house blowing up girl meme. So not great. So this is kind of the outline of what Log4Shell looks like and kind of the concept behind it. So which is not good. There's tons of examples. There's actually a really great video on TikTok from another person in Toronto who can describe this really well. Really look it up. But yeah, so how could we find, and in order to prevent these kinds of issues, right? How could we use this? Well, we could use fuzzing. How could we find such an issue, especially in a large code base such as Log4j? Log4j is a really good example of a large, mature Java code base. Some of that code has been around for a long time. And in fact, in the case of Log4j and the Log4Shell vulnerability, the specific bug that was in the code was there for years and years and years. So it wasn't as if an exploit was accidentally published on Monday and then Tuesday everyone found out about it. This is that was around for a long time. So how could you find an issue in a code base large and complex like Log4j? You could use fuzzing. So one of the great things about fuzzing is that it's very general purpose. Whether you have a code base large or small, whether it's kind of a very new code base or very well-established code base, you can use fuzzing to reveal these kinds of vulnerabilities and these kinds of bugs. So we can use fuzzing and we can try to find Log4j in under 10 minutes. So here's what we're going to do. So I'm going to take a theory and practice approach to show this. And I'm going to do this in order to kind of work up to like how you might think about solving these kinds of problems. So I'm going to use a very, very quick and simple POC to outline how to find such a vulnerability. And then in practice, I'm actually going to run fuzzing against the Log4j library itself. All right, so without further ado, show me the code. So let's open up everything here. Okay. So just for completeness, so as you see here, if you're familiar with Java, I ran a Maven clean install just to keep things neat and tidy. So these lines, info and error, these would be examples of logging lines. So I don't know if Maven uses Log4j or what it uses, but you might want to log this information in a console context. So these info lines, these error lines, are examples of outputs that a logger would have. So let's start with the POC, or like the kind of simple example. And I'm just going to get everything all nice and orderly here. Okay, so here's a very, very simple function. It's actually a class, but it just kind of has a single function. All it does is it performs a JNDI lookup, Java naming, and data source interface as JNDI. And all it does, so it takes a string, so it takes an unsanitized string, so just any old string. There's an exception that you have to handle. If the string isn't null, it performs this lookup action. So what does a context lookup do? Recall that it connects to some resource that could be external to your system. So this could be a local database. It could be a database hosted somewhere else. It could be a web address, like a URL or URI. It could be something else. Maybe it's FTP. I don't know. But you connect to something else in order to connect for logging purposes or for some other purposes. So this is a very simple function. So let's take a look. And so I wrote a fuzz test. Let's take a look at what this fuzz test looks like. And again, because this example is very straightforward, I just create a new instance of this class under test, or this method under test, I guess. And then I'm going to fuzz it with string data. Excuse me. So all I'm going to do is I'm going to call the function, and I'm going to call the function and pass in a string data. The fuzzer will generate strings, and using CI Fuzz, it will kind of intelligently try to find interesting fuzzy cases. So it might start with a given seed that's completely random. So it might be something like, just a set of letters or a set of ASCII string characters, and then kind of go from there. All right, so I write this test. So I have this fuzz test annotation. This notes that this method, or this test method, I guess, is a fuzz test. So similar to a JUnit at test, we have an at fuzz test. And then I'm going to use the fuzz data provider to actually generate the data. So that's what I'm going to do. And so let's run. So CI Fuzz. So I've run CI Fuzz create. Would it generate this or generate the shell of this, or kind of a stub of this test, and then I can fill it in. You can also fill it in yourself. So here it is. I'm going to run, and then I'm going to run this connection manager fuzz test. And let's see what we get. So code is building, running. Okay. And I have found security issue, remote JND and I lookup. So this is the kind of security issue that we're looking for. So this is finding some kind of issue in being able to connect in some way, in a malicious way or something else. So my fuzzer was able to generate some interesting inputs intelligently, and find some way of, or find something that could cause maliciousness in the code. Like there could be some kind of input that causes problems. All right. And it did so pretty quickly. Like, again, like this function is pretty simple. I'm just passing this in string and kind of going from there. So what is this finding? So this finding was given a name, radical macaw, or macaque. I can't remember how it's an animal. It's a a monkey thing. So I'm going to go CI Fuzz finding radical. Okay, so let's see what the finding looks like. Like, what kind of string generated this this security vulnerability? So I was able to get a JNDI lookup. Okay, so I get like a little stack trace here, which is helpful. So, I mean, I can find exactly where it was, but again, like the function is very simple. So I kind of know what's going on there. But here's the here's the actual input. So this RMI, so this looks like a URL, and in fact it is. And if you look up further inspection, you'll find that RMI is a kind of a remote execution protocol for connecting to Java. So for example, let's say you want to execute JavaScript remotely. You want to run, let me back up. If you want to execute code in Java, not JavaScript. If you want to execute code in Java, but that's remotely located, maybe you have like another service or something, you can do that using RMI. So that's a protocol for connecting to this. And we have g.co. I mean, this looks kind of questionable from a URL perspective. So this is an input that suggests that this function as written, right? Because there's no sanitation. Like all I'm saying is pass in a string, some kind of string, and then, try to look up and connect to it. If I pass in this type of string, so an RMI with some kind of URL looking thing, I'll have a possible security vulnerability because I'll be able to remotely connect to some other service. Okay, so this is pretty good. So our fuzzer kind of found this issue, raised this issue very quickly. Again, like I didn't have to really think about inputs. I didn't have to think about like, am I looking for something? I don't have to think in terms of protocols. The fuzzer will simply like find interesting inputs and try them out. So that's what I found. So this is good. So again, very simple. This was kind of a target-rich environment where you're just saying connect to a thing remotely, and it found a vulnerability with doing that. So that's good. So how can I kind of use this approach? Well, so it turns out these lines of code are almost exactly what were in the source of the affected version of Log4j. There was some kind of lookup when you were connecting to some context, and it was not sanitized. So actually a very straightforward bug. If you were looking at this kind of post hoc, if you're looking at it after the fact, it seems very clear that there's an issue. So this is kind of the core of what Log4j does. So let's take a look at Log4j itself. So here is a fuzz test that actually tests Log4j. So if I go up just to be complete, so I'm going to actually use this as what I'm going to test, the Log4j logger. This is really the core bit. This is where you instantiate an actual instance of Log4j, and you're able to pass that around and log user input and send it to console, or send it to your web app front end, or send it back to your data source, like this kind of thing. And I've got a bunch of other things here. And a bunch of other things I'll explain in just a moment. So here's the core fuzz test. So just like I'm doing in the previous toy example, I create a fuzz test at fuzz test. I give it a name, and I pass in my fuzz data provider. So again, I'm using a CLI, and I'm just defining how I'm going to execute this test. And really, all this fuzz test does, very conventional approach to writing fuzz targets. I'm just going to call the function under test, or in this case, the method under test. So I'm going to call log error and pass in fuzzy data and see what I can find. Oh, and then I guess last but not least, I'm kind of creating this logger itself. So I'm creating this logger instance in Log4j, and then I'm going to fuzz it. So what about all this other stuff? Well, in my toy example, it was a toy. So I'm just calling the fuzz target directly, the fuzz test. In the case of Log4j, so again, loggers, like J is a relatively database. There's a lot of functionality. And in general, it's not going to be as straightforward to just find the exploit as it is in the toy example. So in this case, what we've done is we're doing a little bit of setup. So we're configuring the logger in a particular way to help efficiently fuzz it. So this is kind of for performance reasons. You can try this out yourself. And I can link to an example as well, so you can try this out. But so I have the setup method. So very, very similar to how JUnit handles before and after methods. So before this fuzz test is executed, I'm going to call before, and I'm going to call this method setup, and it's going to configure my logger in a very particular way. So really, the way this kind of sets up is that I'm going to disable outputting to console output. And for performance reasons, right? So I'm basically just telling, like I'm not going to append, I'm not going to I'm not going to log, or I'm not going to log to I'm not going to log to the console out itself, just for performance reasons, so that my fuzzing can kind of go a little faster. So this is kind of an advanced approach where you're saying, okay, like I know I'm going to fuzz this. I know it could take a long time because my fuzzing target might take a while. So I'm going to optimize a little bit. So I'm going to call this setup to configure my logger under test, or my method under test, in a very particular way. So I kind of call this using setup. And there's also some additional fuzzing, some additional configuration specific to Log4j. So in addition to calling before method using the @before annotation, if I want to set up my my fuzzer in a certain way, or set up my fuzz target in a certain way, I can do that. There's also some additional plugins. So this is functionality that, again, if I want to modify a little bit how Log4j appends things, or how it manages log input, I guess, I can do that as well. So this is all Log4j functionality that I'm kind of configuring in a particular way for efficiency purposes. You could also just label all this. You could say, well, what's the simplest thing that could possibly work? And that's to basically use these lines here. So this is all configured using the real Log4j engine. I am using the Log4j dependencies here. These two are required, at least for these to kind of reproduce the log4shell vulnerability. But it's important that these are the unpatched, or the vulnerable versions of Log4j and these Log4j dependencies. There have been a few versions since then, but so these are the ones that we're going to use today, because these contain the vulnerability. All right. So this is all set up. It's all been kind of done nicely. So let's follow the same pattern that we just did. So let's do CI Fuzz run. I'm going to run the class name, which is Log4j fuzz tests. And CI Fuzz. Okay, peachy pigeon. So it finds another vulnerability, and look, it finds the exact same vulnerability. So it's able to find this fairly quickly. Let's see, about 5 seconds. But and if we go clear, if we go CI Fuzz CI Fuzz finding peachy pigeon, we're going to get like a more complicated log output than we had in the toy example. The exception is the same. So we're still seeing that you're able to do a remote JNDI lookup, and let's crashing input. Okay. I was hoping to get some other output, but the inputs are kind of similarly they're similar to the toy example. So we're getting some kind of input that's malicious, and it's malicious because we're able to remotely connect through this JNDI lookup. So that's Log4j, or sorry, Log4shell, and so we've found the issue. And we're able to do that pretty quickly. If you try this yourself, you might find yourself thinking, well, that didn't take 5 seconds. It's taking a substantially longer bit than 5 seconds. So there's a couple reasons for that. One is that, let's get rid of this. So one is that perhaps you didn't make these optimizations, right? So, and these optimizations were kind of given by or created by some of the experts that we have at Code Intelligence, people who are very well versed in fuzzing approaches and the art of writing fuzz targets. So that's one thing that might take longer. These kind of optimizations weren't being applied. Like if you don't have this particular setup or this type of configuration for Log4j. Something else, and the reason that running toy examples is really helpful is this thing. So, a concept that's really helpful to understand in fuzzing, and this is a little bit of an advanced topic, is a corpus. So a corpus is a set of inputs, or a corpus of inputs that have been tried or have been sort of outputted or created previously and can be reused or kind of regenerated. And so you can use, so if you run examples like the toy example that I showed, it will generate a corpus. And then if you are able to reuse this corpus or you have some kind of way to reuse it, it can substantially help running your tests, right? You can kind of reuse various inputs. If you have a case, some kind of error or some kind of vulnerability that depends on similar inputs that have already been tried in your corpus, you can do that as well. So that's partially why this ran so quickly. Is I'm able to exploit the fact, no pun intended, I'm able to exploit the fact that I've I've built up a corpus of test cases that I've created. So yeah, so this is how to find Log4j. So there will be a link kind of posted that you can kind of take a look at. This is in one of our example repositories. So definitely try this out with CI Fuzz. Please download CI Fuzz as much as and try it out because it's great. And you can use this to fuzz like any sort of project. So you have an internal project like Log4j. Let's say you're extending Log4j, or you decide to write your own logger for some reason. You could apply the same approach as well. So let's just go back. So that's the code. And so we're kind of coming to the end here. So in summary, so we showed a very common library. This library is virtually everywhere in the Java world, Log4j. It had a severe vulnerability. So you're able to perform a remote code execution in a relatively straightforward way, even just through like an invalid login attempt on like a website or something like this. This vulnerability basically affected everything using Java, using Log4j. So it was pretty bad, 10 out of 10. But vulnerabilities and bugs like this can very effectively be caught with fuzzing. So using CI Fuzz or using other fuzzing utilities, it's actually very straightforward to find vulnerabilities like this, even without in-depth knowledge of what a JNDI lookup is or these kinds of things. So definitely take a look, try this out, CI Fuzz CLI, and yeah, try it out on your code today. Thank you very much for joining. All right, are there any questions? Yes. Okay. So, good question. So, how can I determine if my code base is affected by Log4Shell? So, the good news, is the bad news, good news situation. So, the bad news is this vulnerability is very bad. But the good news is that there's a lot of attention focused on how to identify and fix this vulnerability. So, excellent question. And so I'll share my screen. I'll share my screen. I could turn off my screen as well, I guess. So if I go back to IntelliJ, so there was a very quick patch released. So if you look in your Palm and you see this version of uh, Log4j API or Log4j core, this could also apply to some other Log4j packages and dependencies. If you're using this version 2.14.1, you're affected. So the fastest thing to do, or the easiest thing to do, is to update to a later version of Log4j. The latest is best, but update as much as you can. Barring that, a more if you're unable to update or you're not able to get a later version, definitely try migrating to another logging service. But yeah, it's kind of an easy patch. But yeah, you can definitely do that. Any other questions out there? No more questions. Great. Okay. Well, yeah, thank you. I guess we'll kind of wrap a few minutes early. But thank you for joining me. And I'm happy to talk. You can find me on LinkedIn or on Twitter. So Josh from Four Colors, or you can find me on, and definitely please check out the Code Intelligence GitHub, Code Intelligence testing at GitHub, and download CI Fuzz. All right.